Hello and welcome, ladies and gentlemen. We are here. We are in packet 4 now. We're looking at this getting started activity. Shouldn't take us too long. This should be a nice and short, sweet video. So here we go. Not an illusion. In the previous lesson, you created quadrilaterals and made conjectures about them. When you divide a quadrilateral along any one of its diagonals, you create two triangles. So if we break it up by two diagonals, we create four triangles. So there you go. So one says identify each quadrilateral. Then classify the triangles formed by dividing the quadrilateral using each diagonal. Explain your reasoning. So here we have this little think about how can you use your conjectures from the previous lesson about the properties of quadrilaterals to describe the triangles formed. So I guess we'll just, the first thing it asks us to do is to identify each quadrilateral. So I'll do that first. This is a rectangle. This is a rhombus. This is a square down here, which I will write down below, but I'll just leave it for now. And then this bottom one, bottom right one, is a parallelogram. Okay, so the reason I know this is because I remember the construction that we did, but also you can tell that it has two sides that are parallel, and it has two pairs of opposite sides that are parallel, but also two pairs of opposite sides that are congruent, and these angles look like 90-degree angles to me. So I would say that this is a rectangle. And then it asks us to classify the triangles that it makes. So these two triangles, 1 and 2, are the same, along with 3 and 4. So 1 and 2 are the same triangle, 3 and 4 are the same triangle. So I would say 1 and 2 to me look like isosceles triangles, right? And so we know that the properties of the diagonals of a rectangle are that they bisect each other, okay, and that they are congruent. So they bisect one another, meaning that they cut each other perfectly in half. Okay, and that they're congruent. So if both of the lengths of these diagonals, so if the length from here to here, let's say that was x, okay, then this other line bisects it, it's congruent, it's also x. Because the line that's from top left to bottom right bisects the line from left to right here, then we know that this smaller length is 1/2 x from here to here, and then from here to here is also 1/2 x, and then we would know the same thing because this left to right line, this horizontal line, bisects this diagonal one. So I know that all four of these are equal to 1/2 x, which means that 1 and 2 are both isosceles with these two sides. So these two in number 1, these two in number 2, matching up. And then I know that actually 3 and 4 are also isosceles. Okay, and I know that because these two sides would also be the same length when looking at triangles 3 and 4 there. Okay, so we could break those up into isosceles triangles, and then for your reasoning, you'd say basically everything that I just said, that we know that these diagonals bisect each other and are congruent, so you know that all four of these diagonals when broken up are equal in length, which means that all of the triangles created are isosceles, or they have two sides that have the same length there. So now I'm moving over to the rhombus here. Okay, these triangles, so these ones are all the same. So 1, 2, 3, and 4 are all the same there, and you can tell that just by looking at it. So we would say 1 through 4. What do we know about these triangles? Well, we know that they're right triangles, right? This this little symbol right here, this squared, lets us know that they're right triangles. So I know that they're right triangles. And then as far as, so I know that means one of my angles is a 90-degree angle, but then talking about the side lengths, okay, I know that this, so from here, the center of the circle, to here, I know that that's one length, and then from the center up to the top here, I know that those are two different lengths because this is the radius of a smaller circle than this, because this is the radius of the larger circle. So I know that these two have a different length, and then I know that this hypotenuse isn't going to match up with either of those as well. So I would say it's a right triangle, and that they're also scalene, meaning that all three side lengths of each of these triangles is different in length. Okay, and so yeah, you can kind of look at that. If you can prove that for one of these triangles because they're all symmetrical or they're all congruent, we can prove that for all four. So we just talked through that. Okay, 1 through 4 there. Now going down to the square here. Okay, this one also creates four triangles. We said that that would be the case when we are talking about diagonals, two diagonals. So all four of them are symmetrical. So I would say that these four triangles, again, I would say that they are isosceles, for the same reason that the rectangles were all isosceles, because we know that the diagonals of a rectangle as well as a square bisect each other, and not only do they bisect each other, but they're congruent. So that means that all of these triangles are isosceles triangles. But also, okay, so means that they share two sides. What do we know about their angles? Well, we know that one of the angles of each of these triangles is going to be right angle, which would make it right triangles as well. So these would be right isosceles triangles. Okay, or they'd be isosceles triangles and right triangles, however you want to say that. You could, if you wanted to, you could just say that they're right isosceles triangles or they're isosceles triangles with right angle. That would be a little less mathematically correct. But okay, moving on to the parallelogram, this one. So looking at this, it looks like triangles 1 and 2 would match up, and then 3 and 4 would match up. So not all 4 of them are congruent here. So we'll talk about 1 and 2 first, and then we'll talk about 3 and 4. So the one property that we know about the diagonals of a parallelogram is that they bisect each other, but they aren't always congruent. So we would have to, yeah, so I know that from here to the center is one length, and I know that that length matches from the center to here, because on the big circle, those are both radiuses of the big circle. They're both the radii of the big circle, so those match up. And then I know from here to the center and from the center to there are also going to match up, because these are the radiuses or radii of the same circle that's the smaller circle. Okay, and so because this is a parallelogram, I know that these opposite sides are the same length, and then these opposite sides are the same length. Okay, so all we really know about these triangles is that they have 3 sides that don't match up, because, so I know that, let's say this is x, that would make this x as well. Let's say this is y, and this is y, so now I have x and y as my 2 lengths, and then z, I can tell that this is a different length from both of these. It looks kind of close to y, it might be the same, but we have no way to prove that. Okay, so I know that these 2 opposite sides are the same. So I can say for triangles 3 and 4 for sure that those are scalene. And then if we went with another variable, so I know that now I'm looking at triangles 1 and 2. Well, triangles 1 and 2 already have 2 sides that are different. And then this really long side here, we'll go ahead and call that A, because we used the last 3 of the alphabet already. Okay, A on both of these are definitely different than y and x. So these ones are more easily seen that these are scalene as well. So there you go. There is your getting started activity. Not too bad at all. I hope you guys have a wonderful evening, and I will catch you in the 4.1 activity. Have a good one. Adios.